Okay, great. All right, good afternoon, everyone. Welcome to the new era of 500-watt modular and integrated PV solutions powered by Trina Solar. I think it's wonderful that we are right now being joined by over more than 1,000 people as we are also streaming this live on YouTube. The link is will be shared with all of you guys, the panelists, for having more of your communities join in. I'll quickly introduce myself. My name is Vipul Gulati. I'm going to be moderating the session today. I'm very happy to have been joined by some of the leading industry experts from India, from China, and from other parts of the globe. I think it's a fantastic, powerful session that we've lined up. What's very important is the discussion that we are having today is not only going to help us understand how to reduce the module procurement cost. I think that's where a lot of focus has always been. But I think we are also moving on to discussing how this impacts the overall cost of energy for a complete plant with the integrated solutions that have come up, the reduced cost of BOS. So I would not like to take much of your time and quickly jump onto the discussions. But before I do that, I would like to have a complete feel of the kind of audience we are here. So I'm going to be launching a quick poll just to get a good feel on the kind of people which are present in this. That's great. So we have about 30% people who represent, no, about 26% people who represent the manufacturers, about 25 to 28 who represent the IPPs, about 45% represent the EPCs, about 14% represent our consultants. I'm going to be sharing this polls with all of you as well. Okay, great. So I have the chance right now as a moderator to keep the discussion very crisp, precise. I'm sure a lot of you right now are willing, are more than enthusiastic to find out what is the new era of solar PV, what is the smart in the smart integrated solutions that Trina Pro has launched. And without waiting anymore, I think I'd like Mr. Anil Poluru to start off with his brief presentation on Trina Solar, what are its plans, and how do they sustain in the times of COVID.
Hello, everyone. Good morning. Good afternoon. Let me pull my presentation. Sorry. Yeah. Hi, can you see my slides? Thank you.
Yes, it is okay.
Hello, everyone. Welcome to today's webinar, New Era of 500 Watt Peak Panel and Integrated PV Solutions. I would like to thank all the attendees for taking time out and being here today. I'm Anil Poluru, Senior Manager here at Trina Solar India. I've spent more than a decade in solar PV industry with focus on techno-commercial sales. Today, it is my pleasure to introduce Trina Solar, the most reliable solar panel manufacturer and world-leading PV and smart energy total solution provider. In this presentation, I'll talk about In this presentation, I'll talk about our positioning, our advantages, and I'll touch base on the products and our philosophy. So, world-leading PV smart energy total solution provider, Trina Solar, founded in 1997, one of the earliest Chinese solar companies listed in New York Stock Exchange in 2006. In 2003, Trina Solar built 40 off-grid power packs in Tibet, which was our biggest project at that point of time. In 2010, our feather of cap state PV Science and Technology Key Lab was established, and it was accredited by Ministry of Science and Technology of China in 2013. In 2014 and 15, Trina Solar was globally ranked number one in terms of shipments. In 2016, we have started our Thailand manufacturing facility, which is an important step for our globalization of strategy. In 2017, we got into our 3.0 strategy, version, where we are steadily shifting to smart energy and Internet of Things. Our advantage, a reliable brand. For last 4 years consecutively, we are a top bankable module supplier, 2016 to 2019 as on date. And when it comes to the innovation and growth, our cell efficiency and module power have broken world records 20 times and established over 20 international standards. By December 2019, we have 795 patents on our name, and we are also participated or guided in establishing 95 international standards international standards and Chinese standards. Sorry. So when it comes to the quality, we tightly control quality over every step of the manufacturing process, from silicon crystallization to module deployment in the field. We guarantee the quality of our products with industry leading warranties, 25 years and 30 years. Now, our positioning, global leader of PV industry. Our chairman, CEO, Mr. Gao Zhifan, is a co-chairman of Global Solar Council, chairman of China Photovoltaic PV Industries Association. He was elected as vice chairman of G20 China Business Council. Trina Solar is industry partner at World Economic Forum and is founding member of Private Sector Advisory Board of UNDP in China. A true global company with presence in 110 countries, 100 plus countries and 22 regional offices, 13,000 employees working all over the world. As on date, we must have shipped more than 45 gigawatt of solar panels around the world. When it comes to India, Trina Solar is operating in India for last 10 years with more than 4 gigawatt of shipments as on date. First module supplier to achieve 4 gigawatt of landmark and have local infrastructures like logistics manager, warehouses, service managers, etc., etc. So I'll talk about our business, what we do at Trina Solar. When you look into our business, you can broadly bifurcate them into 3 eras. In Trina 1.0 era, the company was predominantly engages in PV products R&D, manufacturing and sales. In 2.0 era, we are into PV projects development, EPC and operation and maintenance services. We are in 3.0 era, we are into the smart microgrid and multi-energy complementary systems development and sales, as well as energy cloud platforms like Internet of Things. So here you can see our standard module offerings in 72 cell combination and 60 cell combination. We supply standard backsheet as well as double glass panel. My colleague Lim will talk to you about Vertex, which is our new launch with 210 mm cell. Whereas if you talk about our products, we have all the variations like M4, M6 and M12 wafer based solar panel. And here I would like to show you a few signature projects which we have done in India. The left side of the screen, you can see a huge solar park in Andhra Pradesh, wherein Trina Solar has supplied 905 megawatt peak of solar panels. And on right side, you can see a canal rooftop project, 7 megawatt peak, which was built on the Narmada River. Also, we are part of two hybrid solar projects, I mean, wind and solar hybrid projects running in the southern part of India, one in Andhra Pradesh and another one is in Tamil Nadu. And we have a 4 megawatt of double glass installation in Andhra Pradesh near Hyderabad, which is working for last 4 years. And when it comes to the system solutions, over the last 2 decades, Trina Solar has emerged as a top tier project developer worldwide, fostering reliable and long-term partnerships. Our downstream project development business segment provides utility and C&I projects, total solutions and services, including project development, design, financing, EPC, management, operation and maintenance, and asset sales in various countries like China, US, Japan, Latin America, and Asia Pacific regions. You can see here our own projects. By now, 3 gigawatt of projects were connected to the grid, and we are working currently on 7 gigawatt of pipeline globally. These are some reference projects: 14 megawatt project in Japan, 42 megawatt in Vietnam, and Mexico 133 megawatt. In China, it is 300 megawatts. So coming to the residential application, we have a product called Trina Home, which is a combination, I mean, ready-made package. It comes to your doorstep in a carton box when you order it through our distributors or channel partners. It consists of solar panels, inverter, mounting, mounting purlins and rafters, then mounting hardware like nuts and bolts with necessary cables. So Trina Pro is one more solution that we provide. My colleague Andy will speak about it in detail. But Trina Pro is a combination of tracker, module, and inverter with a within software, which is going to optimize the entire operation of tracker and module. So when it comes to the smart energy, I mean, it's like this. As we all know that every roof is not easy or not equal. You have to think a lot when you want to maximize the rooftop installation. Maybe it is because of shadow, or maybe because of the orientation, whatever it is. To address such kind of residential challenges, we have Trina Solar Smart Solutions products called as Trina Switch, Trina Smart, Trina Flex, and Trina Peak. These are all the PV panels with a smart junction box. These intelligent junction boxes would maximize the energy that would come out of the in a given space or a given roof. Next, I'll talk about the smart grid. One project we have done in Maldives under our BES team, which is Trina BES, the EPC division of the company, designed and installed this project. Here it is around 4.6 megawatt of projects, which is distributed in 27 islands of Maldives. Each power pack size was from 60 kilowatt to 330 kilowatt. We had to train the local people over there for the installation of this. There is a huge battery backup, which is again distributed. The cumulative battery backup size is 5 megawatt hours, which is functioning as on date there. And here, energy storage system, which is applicable for various segments like Trina Home for residential, Trina Commercial for commercial applications and industry. There is Trina Mega, which is suitable for industrial application, and microgrids, which we just talked about. And here I would like to talk about Energy Cloud platform. Under the umbrella of brand Trina IoT, the company launched a raft of new data and cloud-based services covering the generation, storage, distribution, and sales of power. Also launched was the Trina Mota brand that will act as management and monitoring services for Trina generation assets. Trina Aurora will incorporate 6 clouds, namely the PV, photovoltaics, storage, charging, operation and maintenance, energy efficiency, and electricity sales. Now I'll talk about our philosophy. We are working with, our philosophy is to benefit the mankind with solar energy. Our CSR activities were recognized globally. And you can see the electricity consumption from 2014 to 2018 there has been a significant reduction of per watt peak manufacturing. How much we have reduced the electricity has been reduced by 39%. Water usage has been reduced by 32%, whereas greenhouse gases emissions has been reduced by 35%. And it is a regular activity for Trina where we improve it on year by year. Here, I would like to talk about our corporate culture. This would be my last slide. A customer-centric understanding, open-minded, honest discussions, dedicated action plan, and excellence to innovate and adoption are our 4 pillars of our corporate culture. I think this is it. Thank you for your time.
Thank you, Anil. I think building on what you just mentioned about the Trina Pro, I think the last time I was in Sri Lanka, I personally saw a lot of systems, Trina system installed in the residential houses. So I think that's definitely something which is very evident. I also remember, if I'm not wrong, I think the Trina Pro solutions were launched on the 20th anniversary of Trina Solar, right?
Correct.
And this has been one of the recent quotes that I've heard is, it's been a conscious move for Trina Solar to move beyond manufacturing of just high efficiency cells and modules, but to focus on a larger integration of all solutions, which helps a lot of developers cut down their procurement cycles and finally focus on what's more important to them, that is bankable and reliable projects on site.
Absolutely.
We have a lot of developers who I'm sure are waiting to discuss this with you one-to-one. But let's find that out after we have a quick presentation from Mr. Gaurav Gaba, who would like to take us through some of the risk which is involved. Gaurav, before I put you up, I just want all the attendees who've joined to just give me a show of hands, those who of you know about Trina Pro solutions. Just show of hands. Great. So I think we have a lot of people. So I think the Andrew and Sean, I think you have a lot of a lot of content to cover and talk when we talk about the Trina Pro solutions, because a lot of people out here who are very intrigued and interested to find that out. I'll be running a quick poll, Gaurav, before I put you on. All right, let's see who gets this right. We have a lot of industry stalwarts here. I think I would also like the panelists to vote in this one. Okay, I see a close first and second. Okay, so here are the results. Anil, would you like to give out the right answer? What do you think?
Yeah, I mean, it's 4 to 4.5 gigawatt. Both options are almost correct. I mean,
I think we've hit it. We've hit the nail right on the spot. Wonderful. Okay, Gaurav. So I think without further wait, let's have you talk about the risk mitigation from a developer's perspective and how does CA operate in this case. Gaurav, you're on.
Good afternoon, everyone. My name is Gaurav Gaba, and I handle business development in Clean Energy Associates, and I take care of India as well as Middle East market. So today, I'm just sharing my presentation. So the agenda for today's presentation will be to give you a brief introduction about my company, the services overview, the services we offer, and I'll also discuss few in-factory QA case studies, the case studies which we witnessed during the inspection. So here is a brief snapshot of our company. So we are an independent technology service and solution providers that mitigates the risk and optimize your storage and solar investments. So if you see we categorize our service offering broadly into four categories, which are quality assurance, supply chain management, engineering services, and market intelligence. So cumulatively, we have experience of more than 55 gigawatt. So out of that, quality assurance is more than 30 gigawatt. Supply chain management, we served more than 21 gigawatt of project. Uh, More than 4 gigawatt of engineering services we had provide, and uh, our market intelligence reports share is also increasing year by year. So we are a team of more than 120 professionals, out of which 75 plus are engineers. And uh, our company was founded in year 2008, and we are a North American owned and operated company with a strategic headquarters in Shanghai, and we have a very strong presence in Asia. So in terms of our leadership experience, our leadership team has more than 150 years of combined experience, and uh, we have our physical presence in 10 countries. Uh, so this is the global footprint. So we started our operations in 2008 from United States of America. So we entered into India market in 2009, and year by year we uh, keep adding more and more countries. So now we have successful client engagements in more than 50 countries and physical presence in 10 countries now. So this is the client base we have. We work with large Fortune 500 companies, mid-size energy firms, and regional boutique solar companies. So there is an interesting fact that 10 of the top 30 global EPCs and 8 of the top 15 global developers use our services. So here you can also see the testimonials from our global clients. So next presentation is about our services. So I gave you a brief broadly categorization of our services. Now I'll give you a further breakdown of our services. So first is the quality assurance and factory audits. So it includes the complete factory audits, also the pre-production factory audits. We provide bill of material analysis and validation, review of quality assurance program and standard implementations, inline 24/7 inline production monitoring, uh, pre-shipment inspections, and container loading monitoring. So all these services comes under quality assurance and factory audit work. So next is supply chain management, which is also like a very main area. Like we have more than 21 gigawatt of experience in providing supply chain management to our clients. It covers like manufacturer due diligence, technology due diligence, the product due diligence, supplier analysis. We provide uh, brief executive summaries for normalization of the different cost, different technologies. So all these comes under supply chain management. So next is the engineering services. So in engineering services, these are the part of our downstream services. We provide on-site testing facilities like EL imaging uh, and other testing services on the site. We also provide independent engineers and honors engineer services, also energy yield assessments. So we have more than 4 gigawatt of experience in providing engineering services. Next is the market intelligence. Here we provide supplier benchmarking program. So we have a very large set of data which we gather from our factory audits and quality assurance projects that we do for our clients. So we present this data in a meaningful form so that our clients can take decision uh, I mean, which supplier to select, which supplier is like doing the more quality work. We also provide forward cost curve and customized market research reports, which directly comes from our leadership team. So next presentation is about the in-factory quality assurance case studies, which our execution team witnessed during the inspection work. So the first case study is about a project which was more than 60 megawatt, and we were doing the inspection in one of the big tier supplier. So the modules were 400-watt mono PERC modules. That was in the year 2019. So the issue that we faced here was during inline production monitoring, when our team did the random EL inspection, they found tree-shaped micro cracks. As you can see in the above image, there is a micro crack that this our team was found during inline production monitoring, but during PSI, that is pre-shipment inspection, there was no micro crack. However, the module serial number was the same. So our team did the root cause analysis. So we performed the EL imaging, EL witnessing on the random samples. So all the modules which were sampled from IPM were kept under like 4 to 6 kept under warehouse for 4 to 6 hours, which are temperature controlled and humidity controlled. So supplier secretly inspected those sample modules, and after finding excessive defects, they were worried about batch rejection during PSI. So what they did, they secretly produced defect-free modules and with the same serial numbers, and replace those bad modules with the defect-free modules. So here's the risk analysis. So this compromised the rejection power of PSI. High percentage of unqualified modules will be shipped to the clients, which may result into the higher field risk in the coming years. And there was an overall quality risk due to non-compliance and unethical supplier practices. So here CA value comes into the picture. So what exactly we did, we rejected a batch of 5,000 modules, which was 2 megawatt, with very high risk of having severe micro cracks. We also asked supplier to provide 8D report for the event submitted to CA and client. Employees involved in that particular event that was laid off by the suppliers, and new batch was produced and submitted for PSI. So here is another case study where we also again are doing the inspection for a big tier 1 supplier. The project size was more than 40 megawatt. It was a polycrystalline silicon modules, 290 watt. So we witnessed that the cell ribbon peel strength test results was lower than the specification. So our team communicated it to the supplier as well as to our client, and based on our client's recommendation, we immediately asked supplier to stop the production and identified the root cause. And in result, we rejected 4,200 modules. So we also did a RCA for this case study. So this Tabor stringer soldering instability is a very common thing. So both machine settings and materials which are ribbon and paste that can impact the soldering strength. So every time like there is any change in the setting, they have to stop the line and do the machine tuning. This may result into a higher cost for the supplier. So the problem was very persistent and the supplier failed to solve it. So supplier did not timely order the line to stop and the product to be screened as per the standard procedure because of the financial impact. This was our root cause analysis about this case. So we also did the risk analysis. So here is a report in which DuPont performed extensive field inspection on over 1 gigawatt. That was 4 million, approximately 4 million modules in the year 2012 to 18, and they conducted visual thermal imaging and IR spectrography and identified issue in approximately 22% of the modules surveyed. So out of 22%, 12% of total defects were related to cell interconnection. So it shows that these weak soldering, these are the major amount of defects come through cell weak soldering. So this is a further risk analysis that our team did. So this lower cell peel strength means that the soldering bonds are weak, which may result into electrical disconnections in the coming year due to temperature and humidity stresses, and those areas can stop producing the energy in the coming years. The another is the due to weak soldering, the excess electrical resistive losses increases, and due to excessive thermal release, hotspots may occur in the modules in the coming year, and that may result into backsheet burning, glass cracking, and EVA browning. So this is the CA value in this case. We rejected the 4200 high risk modules during IPM. CA ensured that the supplier take corrective action as soon as possible, and production resumed without major disruptions to the project schedule and without compromising the quality. So supplier agreed on rejection of 4200 modules. They also released complete 8D report after investigation. We also increased the frequency of soldering strength inspection during the mass production, and they took our approval before starting the mass production. So that's it from my end. Now me and my colleague Anika would be happy to answer all your questions if you have any.
Great, Gaurav. I think that was very insightful on some of the case study that you've presented. I will be involving you and Anika a bit later during the session for picking up some questions. All right.
Sure.
Okay. Now I think we have what everyone wants to know right now is how does this impact the big bucks? How does it impact the financial viability of a project? How do these integrated solutions or high power modules, how do they really make a difference? I am joined by some of the senior most people who have been involved in procuring these technologies, right from SoftBank to Siemens Gamesa to Uniper to Avada. We have a lot of people who we will be engaging with a more one-to-one interaction in a fireside chat. So I think that's going to be something which will really help this boil down to the major point of how does this finally affect the LCOE. But stay tuned for that, because before we move there, I'm going to have a very comprehensive point of view from Andrew, not just from a very narrow geographical region, but also from a very large APAC perspective, since all geographies are very different in its existence, right? But Andrew, why don't before you begin, just if you could cover a point as to what was the need for Trina to launch this integrated solution. Uh, why don't you begin with that and then move on to your presentation from your side?
Sure. Thank you very much, Vipul. And yeah, thank you very much, Gaurav, for such an informative. Trina are looking for ways to understand how we can continually innovate and continue to unlock more and more value for our customers as their projects move forward. A rational. I think you're on mute. Sorry. Vipul, I think you're muted.
Yeah, I'm saying just before you get onto the presentation, I'm going to launch two quick polls just to get a good feel from the industry. I think this will also help you cover up some points during the presentations. Here they are. I can see people are really thinking before putting down an answer. I think that's very good. So here are the results on the screen. I think for seasonal tracking and fixed tilt, I think we are exact 24%. All right. Okay, great. All right, Andrew, I think the stage is all yours. I hope this helped you.
Okay, thank you. I'll just share my screen. Okay, can you see my screen? Yep. Very good. Okay, so I'll just start off by introducing myself. My name's Andrew Gilhooly. I'm Trina's Assistant Director of our Trina Pro business in the Asia Pacific region. I'm based in Melbourne, Australia, so I'll be performing some comparisons that I see between and similarities between the Australian and the Indian utility solar markets. I've been in the solar industry for over 12 years now, 10 of those 12 years actually designing and selling single axis trackers. So that's what we're going to be focusing on today. Just wanted to start by thanking our friends at Solar Quarter and all of the panelists here for facilitating such an excellent discussion here today. And also to the audience, such a wonderful turnout and great to see so much engagement in single axis tracking in such an exciting market as India. Thank you to the audience as well for your insights there. That's given me a really good idea about how to tailor the presentation. So hopefully I have some interesting content for you. I also hope everyone's keeping well and safe in these uncertain times that we live in as well. So firstly, before diving into our tracking technology, I just wanted to discuss some of the drivers that affect whether single axis tracking can actually deliver the lowest possible LCOE in an aggressively low price market such as India. So firstly, if we look at the chart on the left from IHS, we can see rather precipitous growth of single axis tracking globally, and that's only forecast to increase year on year, including for Asia Pacific, which we can see in the orange bars on the top of the charts. And then if we consider the chart on the right hand side, we can see a comparative view of fully installed system costs between India and the US and Mexico, which are two much higher cost markets. And we can ascertain a premium there of 6 cents per watt on single axis tracking over fixed tilt solutions in the Indian market. So our trackers have seen a pretty sharp uptake globally, and that's really been driven by the decline of the cost of PV modules globally. And what that's meant is the relative cost of the balance of system componentry has risen accordingly as the cost of the modules has declined. So if we look on the left, we can see the cost stack of fully installed systems in India, and we can see modules which actually have halved in cost in India since 2015, as I'm sure you're all aware, now accounting for only 42% of the fully installed system cost, with the balance of system comprising the rest of the cost there. So really it's contingent on the tracker manufacturers to continue to innovate and continue to value engineer and really drive down these balance of system costs to bring the balance back into order a bit and catch up with the module manufacturers basically. And we can see the typical cost stack here within the tracker balance of system supply scope there, with most of the cost in the tracker structural components. So now, as I'm based in Australia, I just wanted to show the evolution of the utility scale market in Australia, starting exclusively from a fully fixed tilt base only a few years ago, and then progressing to over 80% of market share for single axis trackers within a very few short years. Now, this is really driven by Australia having a very good solar resource, but it's also where project economics could benefit from the yield uplift possible through specifying single axis trackers. This was also due to the market becoming more sophisticated over time in terms of knowledge and comprehension, and even participation of EPC companies. And as the market got more competitive, then all of those increasing numbers of EPCs had to find ways to aggressively lower the LCOE to a number that met the requirements of the IPPs and the developers through competitive auctions and PPAs rather than fixed feed-in tariffs. So on that note, on the previous slide about solar resource, if we compare Australia and India here in terms of solar resource, we can actually see, if you look on the bottom of these graphs, a broadly similar solar access between the two countries, especially in the regions that are most prevalent in terms of uptake of utility solar. So in Australia, most of the population lives around the coast, and accordingly, that's where most of the utility solar projects have gone in, most of which are single axis tracking. And if we compare that same solar resource to India, we can see vast swathes of India, central and western India, with a similar solar resource, which tends to suggest that the business case for trackers should stack up in most of India. And this is just an overlay of where most of the utility projects have gone in Australia. We can see that cited around the eastern seaboard there. Now, point to note, Australia has only despite having higher labour costs and shipping costs purely through being so far away from anywhere really, Australia has the highest labour costs and shipping costs, but the second lowest LCOE, second only to India in the entire APAC region. So I think that should inspire some confidence that we can really get the LCOE for trackers to a competitive number as well. Now, as I mentioned, I've been working on trackers for the best part of a decade now. I just wanted to address one of the most common misconceptions that I've heard about single axis trackers, especially against fixed tilt systems in equatorial regions. So if we consider this first diagram, we can see the sun path in the summer and the winter, you know, a markedly different path for the sun in the summer, much higher in the sky versus winter. Now, as you get closer and closer to the equator, the variety or the variance between the two sun paths in summer and winter gets closer and closer. So the misconception is that, well, if you're close to the equator, then the business case for tracking doesn't quite stack up because the panels are facing the sun for most of the time. Now, actually, as I'm sure we're all aware, in reality, even on the equator, the sun still travels in an east to west direction. So actually, by going with single axis tracking, you can keep the panels pointing at the sun for the entirety of the daylight generation hours and ameliorate those considerable losses incurred through reflection off the modules as the sun begins to strike the modules at increasingly oblique angles at the start and the end of the day, as is the case with fixed tilt systems. So then in diagram 2 and 3, this is from a study of trackers versus fixed tilt systems in southern India from 2016. So 2016, so it's only monofacial modules, but we can actually see overall the yield boost offered through going to single axis trackers in India back then was as high as 16%. Now, if we consider the cost of trackers is still forecast to decline in the coming years, as well as tracker manufacturers innovating and continuing to boost yield, as well as module manufacturers increasingly improving the efficiency of the modules that go onto the trackers, we can actually comprehend that the business case for tracking in India should only get better and better and actually stack up in most regions. Now, what's very interesting is the business case may actually stack up better and unlock additional value for plant operators and asset owners, where time of use or time of generation tariffs can unlock additional value from the asset. And we can just see what we call the top hat profile in the red line here, which is associated to single axis tracking as compared to the bell curve that's commonly associated with fixed tilt systems. So really, I just wanted to recap on what I feel to be the typical historic misconceptions about what are the project characteristics required in order to make single axis tracking stack up from a business case. So historically, we thought sites had to have low wind load and no snow load to keep the mechanical loads going into the tracker structures within permissible limits. Secondly, there was a perception that sites had to be very flat with very, very, very flat or very mild undulation in terms of topography. That the solar resource to begin with had to be very high, but importantly, the misconception was that the direct normal irradiance or DNI component of the global solar resource also had to be very high, which isn't necessarily the case. And also in terms of geotechnical, that the soil underneath the piles and the footings had to consist of no rocks or no expansive or contractive properties. Also that sites couldn't be prone to flood inundation. Trina actually delivered a 15 megawatt tracking project in Queensland in Australia on a floodplain elevated 4 meters above the floodplain. That was a very interesting project. Also, historically, there's been community pushback that you can't combine agricultural land use and single axis and solar. And we'll see in a later on slide that that's, again, not necessarily the case, especially with tracking. And also that the prevailing labour cost had to be exorbitantly high in order to justify the business case for tracking. Now, as we'll see shortly, I don't believe any of these cases to be required. And actually, with the Trina Pro system, we're actually able to address many of these sites that wasn't formerly the case. All in, the Trina Pro is a smart PV solution that significantly reduces system LCOE. It streamlines engineering, procurement timescales, and it can really minimize the pre-COD and in-service risk by combining premium components, optimized system integration, and smart O&M interconnectivity. It also features Trina's industry-leading solar modules, state-of-the-art tracker technology, and world-class inverters, all integrated into a holistic solution. What I wanted to talk about on this slide, and there's too much detail to go through line by line, but it's just some of the parameters and levers during the engineering and procurement decision-making process that can have a vast effect on project LCOE. So by going with a solution like Trina Pro, a pre-engineered integrated solution like Trina Pro, you can compress your overall upfront engineering and procurement and contracting timescales considerably. And it basically frees up the EPCs to focus on other elements of the plant design like HV or balance of plant and so forth. Now, we're aware that site characteristics, as we saw previously, can vary considerably site on site in terms of geotech and topography and so forth. And that can have a big bearing on the optimum choice of tracker technology on that individual site. Even in a large country like India, as more and more solar is built out, we can expect these projects to become increasingly challenging to construct upon. Now, accordingly, Trina Pro is able to supply a multitude of system offerings. Each one is intended to serve these different facets of the market, including single and multiple actuated rows, single portrait and two portrait mounting configurations, and so forth. Now, as these sites do become more challenging, metrics such as the number of piles per megawatt peak, the slope tolerance, etc., become increasingly pertinent. And so what I really want to draw your attention to is the SP160, which is on the bottom here. That's a single row tracker in a two portrait configuration. We believe this delivers the most value on the most challenging sites. It has a very high slope tolerance in any direction due to its patented spherical bearing in the torque tube, and a very short and wide form factor, as well as a very low pile count, which can approach as low as 153 piles per megawatt. Also, when we combine our high module efficiency into this short and wide form factor, such as on the SP160, it enables a Trina Pro to pack in the corners and fill irregularly shaped sites much more effectively than multi-row trackers. That enables developers and IPCs to develop assets with many more megawatts and attain an asset with a much higher long-term energy outcome. Now, I don't want to steal my colleague Lim's thunder here because he'll focus on the modules, but through integrating high power, high efficiency modules onto our trackers, it enables EPCs to save considerably on balance of system costs, and that can be in the order of 6 or 8%, or even more on extremely challenging projects. As we'll also see from Lim's presentation, Trina have always been an industry leader in terms of bifacial. What I wanted to draw your attention to here was in arid, desert or sandy regions with a good albedo, the combination of bifacial modules onto single axis trackers can achieve yield uplifts in the order of 24%. This is another example where the synergy of using bifacial modules on a 2-portrait single axis tracker where the trackers are higher off the ground and spaced more widely apart enables more irradiance to get in on the underside of the module and boost generation accordingly. This slide just emphasizes the value in opting for a truly integrative solution like Trina Pro, where the interface between the module and the tracker has been rigorously engineered through very extensive product qualification processes. Now we're seeing some, shall we say, some loose partnerships between tracker suppliers and module manufacturers in the market, which are delivering suboptimal outcomes in terms of module integration, the shading of the steel work underneath the module, the DC cabling and so forth. And that's very much not the case with Trina Pro. Furthermore, the use of intelligent tracking algorithms on the Trina Pro platform can deliver further improvements over and above what I presented a couple of slides ago to the yield harvest. Now, this is especially important on sites with a high variability on undulation and irregular solar access row to row. We can also self-stow the trackers in high wind events. We can also stow the panels at a high tilt angle in monsoon rain events to basically get free module cleaning, which can increase LCOE considerably as well. Now with Trina Pro, with the supplier providing more of the value chain, bankability becomes even more of a pressing concern. So as we saw previously on Anil's slide, Bloomberg New Energy Finance have ranked Trina #1 in terms of module bankability for a number of consecutive years now. In terms of the tracker, Trina acquired a Spanish tracker company called Enclave, who have delivered over 3 gigawatts of trackers globally with an exemplary track record backed up by numerous third-party validation from the likes of DNV, Black & Veatch, OST, and so forth. And then on the monitoring side, the Trina Pro solution includes intelligent value adds such as proprietary cloud-based monitoring, which can maximize plant uptime and minimize O&M OPEX through being able to diagnose faults with the site prior to having to mobilize to the site. Now, I just wanted to maybe draw to a close just on some of the value adds that Trina can provide. So at every stage of the sales cycle, so contracting with a single entity like Trina instead of 3 module trackers and inverters, and specifying a pre-engineered solution, we can considerably compress this pre-sales sales cycle. And also through Trina touching more of the value chain, we're able to work hand in glove with your EPC construction teams on site to optimize the delivery schedule of the trackers and the modules and then the inverters, and then on into the commissioning schedule to reach the COD in a much more expedient fashion. Also with single point procurement comes single point accountability, and only Trina can offer unrivaled assurances in terms of warranties and in-service performance of our technology. These are just some of the value adds and support that Trina can provide during the construction phase as well. I've probably gone a bit over time, but I just wanted to step you through very briefly some case studies of where Trina Pro has been deployed. So as I say, over 3 gigawatts globally through Enclave and more lately Trina Pro across 300 projects in 30 countries. The first project, 5 megawatt in Northwest China, very high altitude, very harsh operating environment with high winds and salt blasting and sand blasting in the air. So the technology can hold up in very harsh environments. A 190 megawatt project in Spain, which had very, very high ambient temperature and extreme undulation in the topography. So the Trina Pro solution was able to deal with that very effectively. And then finally, a 30 megawatt in central China, where the low pile count of the trackers was still cost effective to elevate the whole field above the agricultural land below. And this is why I think trackers are interesting for unlocking dual agriculture and solar possibilities within your projects. So I've probably gone a bit over time there. Thank you very much for your consideration. Happy to answer any questions or open up the fireside chat as well. Thank you very much.
Thank you, Andrew. I think thanks for taking our time. It must be what, 4 or 5 p.m. in Melbourne right now?
5:30.
5:30.
Yeah.
All right.
Yeah.
Great.
It's okay, no problem.
All right. So I think now I'm going to bring Mr. Bimal up on stage. Bimal, hi. Can you hear me?
Hi. Yeah, I can hear you. Hi, Vipul.
Hi. So I think earlier we used to meet in a lot of conferences, but now everything is digitized, right? So you and I also need to catch up on webinars.
This is the future.
Absolutely. So Bimal, I think one of the way, there are two kinds of strategies. Now, SoftBank primarily is one of the largest player involved in strategizing procurement and the supply chain framework. Now, there are companies that need to be told, right? This is what it needs to be done, and there are companies who tell. Now, I think you represent that side on the ones who tell that this is how we want it done, right? Now, I think I want your perspective first before you get on one-to-one chat with Andrew. What are the new buying strategies for a player like SoftBank?
So thanks, Vipul. I think I like to highlight as a developer, most of the developers are looking into LCOE. I think the myth which was there in the past that the lowest cost or capex is going to be the key for winning of the project is not the right strategy. So SoftBank as a company, SV Energy, the vertical which focus especially on the renewables, always focus on LCOE. So that's the key mantra, I would put it that way. So we always look into the lowest cost of energy. We might be spending more money upfront as a capex, and our partners who are working with us, they know that our EPC costs are always high compared to the market. I keep on hearing that number of times. Even the equipment which we buy, sometimes they're more expensive than the market. But at the end of the day, we look into the 25-year lifespan of the PPA. That is the key. So you can't focus just on a upfront capex in the first year, and then you spend a lot of money. There might be the project losses, there might be the revenue, there might be the yield, there might be the maintenance cost. Everything you need to look into the perspective. Right. So as long as you're going to focus on that, I think you will be successful.
Wonderful. So now before I think Andrew and Bimal you get one-to-one, I think let's find out, did Trina create a solution for SoftBank, or did SoftBank make Trina create a solution for your projects? I think that's where this all boils down finally. So Bimal, I think over to you with Andrew. Let's have a nice engaging discussion. I just one request, if we can sort of time it max, I think 5 to 10 minutes. I think if we can.
Sure. I will keep it up. Thanks, Vipul, and thanks, Andrew, for this interesting presentation. I think it's really insightful. I will say, Vipul, one thing before I start with Andrew. We share a very good relationship with Trina. They did our first project, 455 megawatt in India. That is the biggest order, I believe, in that time Trina got from any customer, and one of the biggest project in India as a country. So I think, Andrew, you focus specifically on Trina Pro. One thing for the better understanding of the audience, I think, can you explain how Trina Pro is going to be better than the conventional solutions for tracker? Why you see? Because I see that you're talking about an integration solution, which is talking about inverters as well as a O&M, or let's say SCADA being mapped into that. So how do you think it's going to give a competitive advantage or a edge to Trina?
Yeah, thank you, Bimal, and pleasure to make your acquaintance, and great question. So, I think before Trina Pro came along, the trend in the industry was to go disaggregated by your modules from here, your trackers from there, your inverter from here. So really what I think the key, stepping through the key value adds for this, what we're calling aggregated solution, because that's what it is. It's a solution. It's not bit part componentry from here and there. And I think to touch upon your point, the focus LCOE, that's over the long term, right? So the specified technology, there needs to be assurances in place that it is going to perform over the asset lifetime and deliver the required returns to the investors. So really, by going with the pretty much, the most bankable brand in the entire industry, it really minimizes your risk by partnering with us. We provide more of the value chain. We provide a higher level of warranty and in-service and performance guarantees of our technology. And that's really unique to Trina. We can only do that because we provide all of the kit, right? If you're buying trackers from here and panels from there we're seeing a few of these loose partnerships in the market. Now, as I touched upon in my presentation, the integration of the panel to the tracker is not necessarily optimized in terms of underside solar irradiance or access to the diffuse irradiance. But also I think in service, there's a risk of blame shifting or finger pointing. If there are any shortcomings on performance, tracker manufacturer will point to the module supplier and vice versa, and then it can become very complicated very quickly. So with the Trina Pro, the buck stops with Trina. If we're not hitting the numbers, then it's only Trina that's accountable. And hopefully, that can enable our customers to unlock preferential financing rates for their own projects, which can accelerate some CapEx savings or finance savings in the overall cost stack of the project. I think also, through providing the module and the tracker, what we're finding in nascent markets, not necessarily as up to speed with tracking technology as the main markets, the element of engineering support that Trina can provide is valued very highly and actually makes us a bit stickier, as we say it. So, we have very high level of engineering expertise. We know what we're doing with modules and trackers. We can support the EPCs or even the developers on the front end, actually, but we can provide that support in a pre-sales engineering level. I'm using an anecdote here from Australia. Initially the EPCs were somewhat reticent because part of the value out of the EPC is to do the procurement and pick the panels and the trackers, right? But then over time, everybody became so busy and there were so many projects being installed that actually the EPCs began to value the value add of having a solution provider who can provide that engineering support for all of the design considerations within the solar array. And it frees up the EPCs to focus on other elements of the balance of plant, like the high voltage or roads or whatever else. And ultimately, it enabled the EPCs to quote and chase after more tenders with the same amount of headcount and be more productive.
Great. I think it's interesting. So I believe you are based out of Australia. You spoke more on Australia, and then you touched upon Indian market. I just like to understand from the Indian market perspective. You showed some graphs where you said the delta in cost is roughly 15%. And then you shared some slides showing that the yield benefit is roughly 16% or so, plus minus. Now, if I look at until 2015 in India, the solar market, most of the players were using more of the trackers. I personally used more than 0.5 gigawatt of trackers in my previous assignments. Now, after 2015, let's say from 16 onward, the module prices have crashed a lot. And if we compare today, the market price are even 40% or even less than 40%. And during that period, if you look at before 2015, I'm just trying to categorize into two categories. The tracker cost was roughly, if I look at the total cost of the project, was roughly like, sort of 15% to 20%. Now, if you look at the tracker cost on the overall project cost is gone more than 20-25%. So, and another factor which is changing in the Indian market, if you look at the previous scenario versus the new scenario, if we talk about the price in India was like close to 7, 8 cents, 9 cents, 10 cents that time. Now, if you look at it's 3.5 cents. So if you're generating more, you're getting lesser revenue. So how you think that tracker is going to hit Indian market back? I believe most of the developers are still focusing, the major developers I'm talking, I'm not saying that people are not using trackers, but most of the industry people are using fixed it. So how you think, this delta will be overcome in terms of revenue, in terms of the capex increase, and people can start using trackers again in the market. At least from the company perspective, if you look at SoftBank, we are having more than 7 gigawatt of portfolio. We commissioned already 2 gigawatt until last year. This year, we are planning to do another 2.5 gigawatt. So we are not finding it interesting to use tracker based on the dynamism in the market plus the capex and the yield gain. So what's your thought process on the Indian market?
Yeah, great. Good question. And I hope I can change your mind. So I think, two sides of the same coin, right? Bringing it back to LCOE. Dollars per kilowatt hour. So the numerator on the top, the capex and the opex. Tracker pricing is continue to forecast to decline over time, including for Trina Pro. We're integrating the solution more and more into the overall Trina corporate structure as well, including Far East manufacture as well. I think in terms of OPEX, trackers can unlock a lower OPEX in terms of being, especially with the 2 portrait configurations. Trackers are, for the same amount of megawatts, typically spaced further apart, which unlocks easier access between the rows for vegetation management and cleaning and so forth. Now, bringing it back to the other side of the coin for the denominator or energy yield, the example I wanted to find some data that was performed in the Indian market, and that was this comparison between trackers and fixed tilt from 2016, right? So clearly it was monofacial, and it was, I'm going to say, only 16%. Now, when we start layering on, the boost for bifacial on top of that 16%, especially in sites with conducive albedo and ground conditions, semi-arid and dry regions, which is fairly prevalent in India as well, we can take that yield boost up to 20, sometimes 24% through the module and the integration of module and bifacial. And then where Trina can add further value is through our intelligent tracking algorithms, which actively tracks and continually adjusts row to row range of motion to really milk or extract every last fraction of a cent per kilowatt hour of value to really drive the LCOE down as much as it can. So I think, through aggressive cost reduction, which has been the case over the past few years, but I think yield boost is really where it's at in terms of achieving that LCOE. I was really encouraged when you mentioned earlier about SoftBank taking an LCOE approach, which may actually incur slightly higher capex up front, but through taking a holistic view over the asset lifetime, I'm convinced through the stacking of different layers of value that only Trina Pro can unlock for our customers, we can. I'm actually confident we can get there already in some examples in India, and over time, as the costs continue to decline, that'll gradually radiate out into more and more regions of India.
Got it. I think that's great. Good. So we like to understand more on the LCOE part for the bifacial module. I believe. I think that's all, people. I'm just short on time, I believe. Thank you.
Thank you.
Thank you, Andrew. Thanks for your insightful thoughts. Yeah.
All right. Great. Okay, so I think with this we will be moving on to our next presentation quickly. So Shilpa, I hope uh, you are audible on this.
Yes, people.
All right, wonderful. So Shilpa, just a request. I think since we all have our success parameters in business, I think my success parameter is to make sure that we end the webinar on time. So I want your help to do that. So I think try and keep it as brief, crisp as possible, and let's have your point of view on the new era of solar PV modules.
Yeah, sure. Let me share my screen.
Yeah.
Hope you can see the screen.
Yes, we can. Wonderful.
Okay, so a very good afternoon to everybody. I have a short presentation on module reliability today. Just before I start, a quick introduction to DNVGL. DNVGL is a global quality assurance and risk management company, and we are structured into 5 main business verticals to have a focused approach to the industry. We have a legacy of 150 plus years, out of which 40 years has been in wind and energy management and 20 years in solar. And we have almost 12,000 employees working from more than 100 countries around the world. And in India, if you see, we started our operations in 2012. And since then, we have supported for almost 9 gigawatt of installations covering different services, starting from technical due diligences to energy assessments and site measurements and so on and so forth. So before we start with the main presentation, I just wanted to quickly share with you some excerpts from the 2019 Energy Transition Outlook of DNVGL. As you can see from the pictures below, by 2050, solar is expected to contribute to 33% of the global energy mix, and that we are talking from PV capacity increase from 390 gigawatt, which it was in 2017, to 11.6 terawatt scale in 2050. And this 33% share is forecasted to mainly come from the Greater China and the Indian subcontinent regions. So as you can see, the projection of the growth is tremendous from these figures. And also by 2050, solar PV is expected to supply 57% of the power needs in the Indian subcontinent alone. So with this background, we come to the topic of reliability. So why is reliability important? So if you look at the statistics, a large part of the global installed solar capacity has operated for less than 5 years. And during this time, we have also seen a sharp decline in the average price of PV modules, as well as the power purchase agreement prices, and as an effect on the profit margins. And as per a poll which was conducted by PVEL, the industry feels that an underperformance of 3 to 6% is itself enough to render a project financially non-viable. And we have also seen in the past 5 years a lot of technological innovations and a lot of new applications as well opening up, except for example, the floating solar applications. So it's a known fact that the updation of the standards are not keeping pace with these improvements in the technology as well as the new applications that are coming up. And there is also a dearth of long-term field data to prove the reliability of these new technologies. Now, there's a general view, or it's an industry consensus, that IEC testing only helps to identify the initial infant failures in the field. As you can see from the widely used graphic onto the right from IEA, the main degradation mechanisms or the failure mechanisms of the solar module is categorized into an infant failure, midlife failure, and wear out failure. So as I mentioned earlier, the IEC testing is addressing this infant failure area of the operation of the life of the module. So what can we do in this? So if you ask us from our perspective, the measures that you take for ensuring the reliability of a module should start from the product qualification stage and should continue through the manufacturing as well as to the operational phase of the plant. So in the product qualification, a couple of points that can be taken care is, of course, evaluation of the factory, and also confirming that the product has all the necessary certifications, that is the basic IEC certifications, and also certifications with respect to the common terminologies or the common degradation mechanisms that we see for the module like LID and PID. I would also like to invite your attention to the last 2 points which I have put in the slide here, which is on the extended reliability testing, which is basically a testing of the wear out mechanisms, that is the failure of the modules during the mid-life and the wear out phase of the operation of the plant, which necessarily means that you test much more than the IEC durations for the tests which are stipulated, which is around 2 to 4 times. And the last part and the most important is the focus on the bill of materials, which is being supplied for a project. And it's also needed to ensure that these above reports are applicable to the agreed BOM for any particular consignment as well. To prove this point, you can see the 2 graphics below. One on the left-hand side is a picture from the 2018 PV module reliability scorecard. And the one that you see on the right is from 2019 PV module reliability scorecard. Basically, these 2 modules tested were having the same model number, manufactured by the same manufacturer, and also has the same data sheet parameters. And both these modules have passed the IEC 61215 requirement. So if you see closely, only when the duration of the testing or the stress that is imposed on the module is extended beyond the IEC stipulated levels is where you see the difference in the performance of these 2 bill of materials. Now, I would also like to share some findings from the 2019 PV module reliability scorecard, which also reflects the results of the tests that we have done on a lot of new technologies that has come up. As we have seen, the thermal cycling and PID top performers rose in the 2019 reliability scorecard compared to the 2018 levels, which is a good indication. There are more top performance in PID than any other PQP test, which is an indication that the industry has a hold of this particular issue, and suitable measures are being taken to implement that in the module manufacturing itself. However, on the dynamic mechanical loading test, the DML sequence and the damp heat performance, the top performers fell with respect to the historical results. In fact, for the damp heat test, a significant number of tested modules exhibited greater than 4% degradation after the test. So this, if you connect with what I was mentioning to you earlier, that an underperformance of 3 to 5% itself will determine the financial viability of a product. So this is one area where it needs more focus from the manufacturers and the industry in particular. As regards the conventional poly and mono-based modules compared to PERC, mono and poly, similar reliability results were observed across the PQB test. And over 30% of the module bill of materials assessed failed 1 or more test criteria. And 10% of the BOMs had at least 1 safety failure. So this reinstates my point in the previous slide. The bill of materials need to be focused more closely when you are looking at the reliability of the product. Now, with respect to the 2 new technological advancements in terms of the half-cut cells and the multi-bus bar, edge isolation and soldering were concern areas if the process was not well controlled at the manufacturer. And in terms of multi-bus bar, we have also seen good and bad results from various manufacturers, including some failures which were observed after the thermal cycling test. So as I mentioned, once the product qualification is done, now your risk shifts to the manufacturing phase. So what can be done during the manufacturing? Of course, the factory oversight during production goes a long way in ensuring the quality of the modules that you are getting shipped for the project. And the second thing, what I want to focus on is the statistical batch testing. This typically is a list of tests which you would do on each batch which is manufacturing for a project. And this, the list of tests is chosen from the standard IEC test protocols itself. And it helps to screen the serial defects or any BOM related issues, or any issues related to the quality systems which are in place at the manufacturer. This kind of infant failure contributions can be identified through the statistical batch testing. And what we have seen is that a sample size of less than 0.1% itself can be effective in establishing confidence in the quality of the modules being shipped. As you can see from the picture there, if we have to get 95% confidence level that 95% of the batch is defect free, you need to test around 45 modules out of 70,000 modules. So this doesn't add much to the capex or the initial upfront investment of the project, but it goes a long way in making sure that the quality of the modules which are being delivered for the project is of desired quality. This is a case study that we have from a utility scale project in the US, where 18 PV modules were randomly selected from the factory for screening for defects. And to the right, you can see the tests that these modules were subjected to. And each test had 6 modules per test. And you can see the failure rate of 44% that we have observed from this batch testing that was done. Now, moving on to the operational phase.
Just a reminder, we'll have to be quick.
Yeah. So on the field data analysis, advanced system analytics goes a long way to identify the deviation trends in the plant, and also periodical IV and eval testing of samples selected based on the SCADA data. So in this context, DNVGL has done field tests on more than 1,500 modules, which involve 22 manufacturers, both domestic as well as imported. And these plants had an operational history of 1 to 3 years, and the plant locations were spread all over India. And it also covered the technologies of standard mono, multi, and mono-PERC modules. So you can see the results here. Here, what we are trying to capture is a deviation from the warranted power, which is guaranteed by the manufacturer. And you can see that large quantum varies from minus 1.3 to 1.7 to 2%. Negative meaning that the measured wattage of the module is above the warranted power of the manufacturers. So this, the statistics that we see in front of us is, as I mentioned earlier, is from a sample size of 1,500. So when you extrapolate it to the plant capacity, then it becomes sizable figure to handle. So with this, Vipul, I think I'm done with the presentation. Happy to take any questions later on.
Sure. Thank you, Silva. I think I apologize for putting the pressure on you, but I think these times call for it. Anyway, I think that was very, very great. So the other panelists, we are getting a lot of questions based on the earlier presentations as well. So we have some questions addressed to Andrew, some to Anil, some to CA regarding trackers, CA's plan for India market. I am going to be putting up all these questions to you at the end of the session. But now I think it's time for us to bring in Lim on board, who is heading the product and marketing for Trina for the APAC region. Lim, hello, hi.
Yeah, hi everyone. Thank you for participating in this webinar today.
Thank you. Lim, so I think when you talk about the Indian market, Indian developers primarily when they bid, they have a period of about 12 months to get the entire procurement done. In some cases, about 15 months for a particular state project. So I think before we move on to the fire chat and I bring in the other people, what's really important is if you could in your presentation also try and highlight how does this help in a geographical procurement for a lot of Indian developers who are right now expanding in various parts, at least in the Asia market. And secondly is how does this help them in the procurement of the final in the supply chain procurement for the modules?
Yes, sure. I will try to cover it in the presentation. Yeah, okay. So I will share my screen now. Okay, I think everyone can see my screen and hear me. So once again, thank you everyone for the time today to join this webinar. So I'm Lim, the product manager for Trina Solar, handling Asia Pacific. So I've been with Trina for about coming to 9 years, and I've been supporting most of our customers on product related and some of the marketing issues. Okay, so let me start off with some brief introduction. I think we have all have different sources of information about the energy structure and how energy is going to develop in the coming 20-30 years. So there are different data from different research companies, but one thing that we are very sure is that definitely we will see solar being a very key component going forward of the power capacity on a very global basis, especially in terms of in the renewable segment. Solar will be definitely one of the key selection or the energy of choice going forward into the next 20-30 years. At the same time, we also see coming from the past 10 years how the solar system has developed, and now from the very high LCOE to the current lower and lower LCOE, making it a much more feasible energy choice for many of the energy generation providers. So we do foresee that the LCOE of utility scale PV plant might continue to be lower, trying to reach plateau maybe in about another 10-20 years time, as we see the component prices reaching lower price. So as we all understand, LCOE, the levelized cost of energy, is a holy grail which most of the developers and generators are looking at when they are evaluating a solar project. So as we can see, from the LCOE perspective, is actually total cost divided by total power generation, and what consists of the total cost makes up of the initial investment, the OMN costs, and the other running costs, and finally we minus whatever is left at the system residue. So if we look into the specific details at the initial investment, then bulk of it will come from the module cost itself, and also the BOS cost of the other inverters, racking, and the land cost and others. And then we divide by the total power generation, how we can get more power out of the solar system that we have installed. So we are trying to decrease the total cost and increase the power generation so that we can get a lower LCOE. And just to give everyone, just to recap again on what we look at, how the solar module has developed over the past 10 years. We started off, probably we look at from 2009, where we have the high density plus high resistance and the back surface field technology that is used in our mono module. Then another in 2012, we also introduced the selective emitter. And then between the period to about 2 years ago, mainly with the shifting in mono and monoPERC. So for the past 1 year, then we see the shift now to half cell, multi-bus bar, and we're also increasing the size of the wafer. So as you can see, from 290 watt 10 years ago to what we can achieve now, there's almost 70% increase in the power of the module. And at the same time, we notice the trend starting from early days where we have a mix of between mono and poly, where everyone is trying to decide, should we go with poly or should we go with mono? But for the last 3 years, based on the continuous demand and improvement on the power bin requirement, we can see that the industry is shifting very much towards mono to achieve the high power bin. So which is why we do observe this trend that the market share of monoPERC is increasing, and also supply itself is also increasing from most of the big module manufacturers. And also we see the trend that from very old days of 125 mm solar cell, where we progressively reached to 158 and then to 166 just maybe about 1 year ago. And this year from Trina, we are looking at 210 wafer size. So this is the overview for the next 3 years on the roadmap in terms of our cell efficiency and module power. So our current highest power will be, the 500 watt module, which I will talk about later. You can see on the right side of the table the kind of trend that we are looking at, which is pretty much in line of the power bin increase of between 3 to 5 watt every year on a similar technology as production ramp up. So this is the overview of Trina product portfolio in 2020. You can see we have the range of products covering starting from the left on Honey Black, which is targeted for the residential market. And then we also have a special N-Topcom product, which is also targeted for slightly bigger, or I would say residential and small mid-sized CNI market. And then our key products will be from the Tormax, which is used in most of the utility projects. So we have a mixture of poly and mono-PERC, and you can see the different cell size configuration that we have. And of course, now we are also focusing very heavily on our bifacial module, which I think previously my colleague Andrew has already introduced how we can use the bifacial incorporated with the tracker to even achieve better power generation for your solar plant. So this is a current list of products that we are selling in India. So you can see we cover from the smaller 60 cell. I mean, because now we offer in half cut, so it's 120 cells all the way to 144 cells. And then for our new Vertex 500 watt module, this will be the 150 cells. So all along we have been supplying the backsheet frame kind of configuration. But for the bifacial module here, we will be offering in the dual glass and frame platform. So Trina has been basing our progression on these few 3 key technologies, which is the multi-bus bar, half cut, and the dual glass platform incorporated with the bifacial. So together with all these, we put in together and achieve higher and higher power bin. So the details of this technology I will explain slightly later under the 500 watt module. At the same time, from Trina, we have been actively promoting the dual glass platform, which we have used already on our 158mm module 166 and also on our 210. So some of the benefits that we can see here is definitely there's the fire safety class, the highest at class A, and then we also have the longer power warranty of 30 years, and it's definitely much more resistance to environmental corrosion from the sand, acid, and salt mist, which is why we are confident to offer a lower power degradation for the dual glass module. And in terms of track record, we have really shipped more than 3 gigawatt globally. And now we have also added the frame into a dual glass to make it compatible with most of the structures and also the tracker system. So this is some of our manufacturing and delivery capability. So for the dual glass itself, we are looking at up more than 10 gigawatt of production capacity for this platform. And we have about 20 patents on the dual glass module. Together, we have also have 3 international standards already applied under SEMI standard. So on our 166 module cell size, which is the DE17M. So for this platform, basically, we are looking at power module up to about 450 watt, and it incorporates all our key technologies like the mono-PERC, 166mm wafer, half cut, multi-bus bar, double glass, and bifacial. So this is one of our key products that we are already selling into the market, not only in India, but on a global basis. So when we do a comparison between higher power bin of 440 watt versus 158mm cell size of 405 watt, we can see in terms of the DC BOS savings, approximately about 0.008 cents per watt in US dollars. So of course, the key savings will come from on the number of modules. When you have the same project size, using a higher power watt module will definitely reduce the quantity of modules that needs to be installed to achieve the same system size. So from the less number of modules, it will branch off to the savings in terms of the cables, component box, foundations, structures, and everything. So this is where the key savings come from when we use a higher power bin module. So for this year, 2020, Trina is very excited that now we have opened up the 500 plus module era. So this is our Trina Vertex, which we expect to hit 500 watt and above, together with square PERC monocell high density technology, and also offering in the dual glass platform, which will give us higher reliability together with a lower derogation and longer power warranty. So this is an integration of all the innovative technologies that we have, starting from the top left corner, from the wafer size increase. So you can see, the size itself is almost an 80% increase compared to the previous. And then we will also be incorporating the multi-bus bar. So conventionally, our multi-bus bar has been 9 bus bar. But for this Vertex module, we will be using, because the surface area is bigger, so we are putting in 10 bus bar to achieve the same kind of effect that the multi-bus bar can bring to the module. And instead of the half-cut cell technology, we will be implementing a 1/3 cell cut using a non-destructive cutting, which will be elaborate in the following slides. At the same time, we also adopt the high-density encapsulation technology. So this is basically the key to minimize the space between the cell and try to pack as much as possible within the module itself, so that even when the wafer size is increased, we do not significantly increase the size of the module. So we try to keep the size of the module within the optimal range, and we do this by reducing the space between the cells. So as you can see, as I mentioned earlier, from the very early generation of solar cell when it started off, the way back in 1965, that is even before the commercialization of solar system, until the recent, maybe like 15 years ago, where we see the most common 125 mm started off with the boom in the solar industry. And then from there, we have progressed now until the 210. So I think currently in the market, you do see, there's many different cell size offered by different suppliers. And this can be a bit confusing to a lot of our customers. So, but looking ahead, or now for the next, at least next 5 years, predominantly to achieve this kind of high power bin, definitely, a bigger size wafer will be required, which, as of current, matching with the semiconductor technology, that will be the 210 mm wafer size. And how then, in terms of the 1/3 split cell? So this is how, there's a lot of research that has been being done on how we can increase the power. So as you can see in the table here, we have half cell, 1/3 cell, and 1/4 cell, and some even in the market you can see 1/6 cell. So these are all the different kind of configuration that we can try on a solar cell itself to try to increase the power. But at the same time, we also need to consider the ISC and the VOC. What is the impact of each technology or each method, and how will this affect when we are doing our design and in terms of number of modules in the string. So from Trina here, we have selected this 1/3 cell, basically as the optimal to balance between the VOC and the power itself, so that we can still try to connect the modules. Like I think in general now we are looking at 29, 30 modules in a string, depending on our site location and the kind of inverters that you are using. So we are still trying very much to keep to this very similar design, so that there will not be very much impact to EPCs and developers when they are doing their solar system design. So at the same time, we have also improved our cutting technology. So from the previous half cell technology, which we are using the laser melting and high temperature, together with mechanical separation, which might have some rough cutting surfaces. So on this 1/3 cell, we use a low temperature and non-destructive cutting. So it's a very smooth cutting with no cracks. So this will also help to protect the cell. And based on our mechanical performance tests, we do see that the mechanical strength using this cut technology is very much similar to a full cell. At the same time, Trina has also used the multi-bus bar technology, replacing the standard flat ribbon solder ribbon with a round wire ribbon, and this increases our light capturing effect and translate to a module power improvement of about 1% to 1.5%. And as you can see, we use multi-bus bar, so this will reduce the current path and lower the series resistance by 10 to 15%. So this will reduce the power loss from resistance itself. And this is the high density encapsulation technology. So starting from the left, you will see the traditional module where the cell distance is about 2 mm. And then on the extreme right will be the shingling technology, where we call it maybe like overlap, where the cells are stacked on top of each other. And then from Trina here, we achieve the balance between these two to reduce the cell space to less than 0.5 mm. And this is from what we see, this is the most optimal in terms of to achieve the efficiency of the modules and also to maintain a very high production yield of the modules. Because when we use the shingling technology itself, this requires a very high level of production process. So which is why the production yield will be lower, and because of the breakage, incorrect alignment, and this will also directly impact to the cost of manufacturing this module. So we choose this high density small gap technology to try to achieve this balance between power, efficiency, yield, and cost. So we compare again, between, as you can see now, from a 405 watt, 440 watt, and 480 watt, the kinds of savings that we can get when we use even a higher power module. So this I think also, as my colleague Andrew has also highlighted, so as we increases the power of the module, and if you use it in combination together with a tracker, we can see quite significant reduction in terms of the BOS and the LCOE that we are trying always to keep it low. So in terms of the materials itself, we have both the backsheet version, the D18M, and the bifacial DG18MC. So we have the pen file and data sheet available. And as you can see, in terms of dimension for the backsheet module, is about 2.1 by 1.09 and weighing about 26.3 kilo. And for the bifacial will be slightly bigger and a little bit heavier, about 3 to 4 kg heavier at 30.1 kilograms. At the same time, we are also doing some case study in China, our own internal test site projects that we are incorporating the modules of 166 and also 210 together with our tracker in the 2V and 1V configuration. And at the same time, we have an external demonstration project in China, Huanghe. So this is based on we'll be comparing between different kind of arrays between fixed tilt and tracker system itself. So I think at the same time, we have also talked with some of our Indian customers, and they are very, very interested to adopt these higher power modules, which I believe we might release some newsletter on these Indian projects using these high power modules. Okay, so with that, thank you everyone on this short presentation. Hopefully, we can stir up your interest on our solar modules. Yeah, thank you.
All right. Thank you, Lim. I think your presentation definitely answered a lot of questions on the technology, cell dimensions. I think that was very good. I could see a lot of people inquiring about the 500 watt high power module. So I think wonderful, great job there, and a great product definitely. All right, I'll now I think I would like to bring in Mr. Deepak Saxena in, Vice President at Avada Power. Mr. Deepak, hi. Mr. Deepak, hi. Can you unmute yourself and switch?
Hello.
Yes.
Yeah. Okay. Thank you, Vipul.
Yes. So, Mr. Deepakji, I think I'd like to get your quick perspective on the 500 watt high power module. But before I do that, I'm just going to run a quick poll here to see some of our industry friends what they have to say on these modules. The panelists can also vote on this. Okay, Lem. So I think before I share the results, let me get your quick take. What do you think would be the maximum installed for 500 watt? What do you think?
This is definitely going to be a utility scale product.
Okay.
But as all new technologies have initial hicks on the users, like we are one of the biggest users in the India. When I was listening to the presentation given by the Lim, the few obvious questions which has come to my mind, I will read one by one and then Lim can respond. Number one, the ingot manufacturing diameter has been increased tremendously. Now, when it is a seed type of technology and the diameter you are increasing, will it affect the consistency of the crystal ultimately, which makes means wafer and then crystal? Because ultimately the purity of the ingot, because you are increasing the diameter of the ingot when you will be cutting a 210 mm wafer. That is question number one. Question number two, you were telling 1/3 sizing with gap of only 0.5 mm. Now, this 0.5 mm as a process, manufacturing process, appears to be very difficult to manage. And if anything goes non-controllable, then there may be a wafer to wafer short circuiting, or if anything, because margins are almost nil, margins are not there, and this creates some doubt that whether this thing will persist long or not. Third thing, you are telling the round ribbon technology. As you know, definitely with the round ribbon technology, you have improved on the reflections and the use of the light source in generating power. But always any round figure, it is very difficult to do the soldering or to make it stick on a flat surface. So the manufacturing quality process in using the round ribbon technology also include some thinking that how this process will be managed. Another thing that overall, if I see the module size is increasing almost by 20-25%. Wafer size is increasing by 20-25%. Now, with this larger size of glass which you are using, are you improving on the quality of the glass for the maximum bending so that the micro cracks does not develop in the process of erection or in the lifetime? Because in earlier modules of 158 or 156 mm cells, the maximum deviation which generally users used to allow was 0.5 or 0.2 mm. With larger this thing, are you trying to reduce this deviation in the glass deviation? Number 4, with bigger module, the wind forces acting on the module will be very high. In India, the wind forces are high. With higher wind forces, do you think that the frame size or the material in the frame or the dimension of the frame should be made slightly better than the earlier version, because each module will be seeing much higher wind force compared to the earlier generation of the modules? Then last thing which is slightly worrying is that the back sheets will see the much more shrinkage and expansion. With a bigger size, the absolute value will be high. So are you doing any change in the back sheets which will be used in the bigger modules?
Lim, I hope you've made a note of so many questions together.
Yeah, thank you, Mr. Deepak, for your questions. So let me try to explain a bit more. So starting from your first question of the ingot itself. So I think from this perspective, what we are doing is in line with what the semiconductor is currently offering in the market. So adopting from the semiconductor ingot is how we adopt from there to use it onto our solar cell. So when we talk about a bigger surface and a bigger area itself, I think with proper control in the growing process, we will still be able to maintain the same kind of purity that we are using even for the smaller size wafer. Okay.
Okay.
Yeah. Then for your second question, I think for the round wire ribbon, so in terms of this multi-bus bar technology, I mean using the round wire ribbon, in industry itself, Trina is one of the first few manufacturers to adopt this technology. So before we actually implement it onto the production level at big scale, we are working with the equipment supplier on how to perfect this soldering and incorporating it into our production process. So we have done extensive testing on the peel strength itself, and have verified that the peel strength of this wire ribbon is definitely comparable to the flat kind of solder ribbon. Okay. Yeah. Then in terms of your question on the glass size, yes, because the module itself is becoming bigger and bigger. So previously when we started off with the Dual Max double glass platform, we actually is a frameless. So now we have added the frame onto it, further strengthen the module. And I think for the glass thickness itself, now we are keeping it at about 2 mm. So this is trying to achieve the balance between the mechanical integrity of the module, and also not to have too excessive weight on the module itself. So in terms of the bending, I think from the module perspective, this also needs to be considered on the mounting method itself. So for the mounting positions and the rails used, with a combination of these two, then I think we are quite confident that this will be able to withstand the kind of wind load that might happen on this installation site. Then the last question on the backsheet on the thermal expansion. I think this is a interesting question on because of as the surface area get bigger, see expansion itself. So I think as of now we do not see a significant problem at the moment on this aspect. And at the same time, as you know, this is a new module which we are launching into the market, and we are also starting on some of the extended reliability testing to make sure everything is okay, because it is still based on the previous platform technology. It's just that now you can see everything becomes a little bit bigger.
Okay, one more thing, that the margin between the cells, you have made it 0.5 mm. So that is too less, means to think of, means.
Yes. Yeah. So I mean, this is how we are looking at. As you can see, the conventional is a 2 mm space. So we are thinking, will it be better if we put it to 1.5, 0.5? So there's a few options that's available. But I mean, from our production confidence level, we decided to go with a 0.5, which will help us to get a smaller overall size of the module. So far, I think from the production perspective, we are maintaining a very healthy yield on this 0.5 mm.
All right.
Okay.
Thank you. Thank you. Thank you, Deepak Senaji. Thank you very much. Okay, I'm going to bring Venkat in now. Venkat, what are your initial thoughts on the 500-watt high power module?
Initial thoughts are positive. So Vipul, thanks again for bringing me on board. So initial thoughts are, since the middle of last year, technology has been moving so fast. So I've been in the industry since 2008, actually. My first module was a 280 watt 72 cell. Today it's double that. The module size has not increased too much, but still the outage, energy density has gone up exponentially. So my first concern or thought would be, so many technologies are being brought into a module at the same time, be it half cell, multi-bus bar, larger cells, more cells, larger wafers. From a bankability perspective, right, we still need to see how reliable these modules are, especially since a lot of the projects are being financed from third-party funding. So like Bimal has said, and we have had discussions in the same webinar, we shouldn't look only at the first or second year of construction time frame. We look from a longer perspective, 10, 20, 25 years of PPA. So earlier, the module technology increments were minimal. Maybe we went from 2 to 3 to 4 and 5 bus bar. But since the middle of last year, there's a lot of things being added to one module, and it's still a new product out there. So I'd love to see Trina and other manufacturers also share bankability information, right? And I think there is a step taken by Trina. For example, Lim said they're starting a field installation, pilot installation with the 450 and 500 watt peak modules to see how the modules perform in the field. So that kind of data will be very useful to ensure how good the modules are performing in a live field process. So it's interesting, but yeah, let's take a look in the long term, see how these modules perform also. Yeah.
All right. So Venkat, do you have any questions for Lim on this in particular?
Sure, I do. Hey, Lim, thanks for the good discussion. So you presented today both M6 and M12 versions, right? And I think this 2020 and maybe even early part of 2021 is going to be a transition year for a lot of the module companies because of two major competing wafer technologies. And I think to make use of that, I think Trina has released modules with both wafer sizes. Which way do you see the industry going long term, Lim? Is it the M12 size or the M6 size, or Trina also? I think you make your own wafers. Is Trina planning to bring in any modules with your own wafer size specification? Can you throw some light on that, please?
Yeah. Hi, Mr. Venkat. Thank you very much for your question. So I think, in terms of how the wafer size is going to develop, this one will also, depends on the reaction from the market, how our customers are taking to, the 1.6, the M6 and the M12. So whether, are they able to accept this larger kind of a module? When you use it in your projects, do you face any problem, or do you foresee any problem that might happen? So based on the market reaction, we'll also try to adjust accordingly on how we can ramp up the supply or adjust the ratio between these two modules.
Okay, so you still, it's a wait and see game so far. Okay, you're saying which way the market moves. Thanks for that. I have two more questions, if people allow me. One
Absolutely.
is there's a big discussion on LETID, right? Especially with PERC coming into picture big time last year and this year. Most module manufacturers have moved enormous volumes of production over to the PERC technology. And when you do that, even 5 years ago, this LETID problem came into the picture. A lot of process steps have been improved at the cell level to mitigate this. What steps has Trina taken to mitigate LETID on their modules? Can you share some information on that, please?
Yeah. So for the LETID, currently, what we are seeing is that some of the measures that we are using in our production control is still following quite closely with the LID process itself. Because as of current, if you can see LETID, there is some standard test that is proposed by like different testing agencies. So we have also validated some of our models with these agencies to see how under this proposed test condition, what will be the derogation of the module. I think as of now, the reports that we get are positive, is still within the pass-fail criteria set by the agency at the moment. So of course, going forward, we will still continue to look at and research on how we can further improve and look and seeing whether do we see any feedback from customers or from market or even from other suppliers on this LETID phenomenon that is happening in the field installation.
Okay, thank you. Just two more questions. One is, what is the wafer thickness? So the wafers are getting bigger. Earlier it used to be 300 microns and 250. Today it's 180 plus or minus 20 micron thereabouts. For the M6 and M12, what wafer thickness is the industry looking at in general?
I think for the wafer thickness on M6 and M12, generally we are still keeping it to about 180 micron plus minus.
Okay, fantastic. The last question. So you showed a very interesting curve chart with N-type TopCon, right? So again, looking at LCOE perspective, N-type offers a lot of advantages, especially with TopCon, maybe a better temperature coefficient, no LID in the first year or very negligible LID in the first year. What is Trina's views on, bringing that into high volume? I think that would be a big game changer with bringing a major company like you, bringing N-type into a volume play and also offering it at a very competitive price. How much of a part of your roadmap is N-type technology?
Yeah, thank you for your interest on the N-type. So I think for the N-type now, definitely Trina is also looking at how we can adopt this N-type into mass production. So I think previously, if you look at from historical N-type wafer itself, first there is we need to consider on the supply side whether are we able to get large volume of N-type wafer, and then with the supply in place, then when we transfer it to mass production in terms of the equipment and everything and the capacity, from the past until now, generally N-type manufacturing process involves a few more steps compared to P-type. So which is why combination of process and supply, there is still a cost difference between a P-type and an N-type. So going ahead, definitely we do recognize that for N-type, like you mentioned on the lower LID effects, lower derogation, and maybe slightly higher power. So we will definitely continue to study the balance between this and how we can bring the cost down to a manageable level and make it into a mass production product.
Perfect. Thank you so much, Lim. Appreciate it. Really nice to get to know your products, both in modules and the full tracker systems. Vipul, thanks so much again for the opportunity to be present and ask questions of Trina. Back to you, Vipul.
Thank you.
Vipul, can I have one supplementary question?
Yeah, just one second. I think Venkat, Siemens Gamesa is also one of the leading players when it comes to EPC services, not just in India but as well as Southeast Asia. I want your take, a quick take for the India market this year. What do you think the size of the Indian market is going to be in the financial year 1920, considering the COVID impact that we have? And then after this I'm gonna put it to test to all our attendees in the form of launch of a poll. So let's see how close you get to this. The market
Sure,
size.
Vipul. Yeah, I'll take a gamble on that. Even last year was a challenge. We did only about 8 gigawatt, and I was expecting similar numbers in January, but a lot of things have happened since January, and I think that's the reason for your question. Very, very positive aspect. Maybe if we consider, maybe I would look at 7 gigawatts. If we go on a lower side, the bearish side, I would say maybe about 5 gigawatts. So between 5 and 7 for calendar year, and also for the financial year. That's where I would put today.
Deepakji, I'll get you in on this. What do you think is going to be the market size?
I roughly agree with Venkat.
Okay, so you think it's 7 gigawatt?
Yeah, yeah.
All right,
between 5 and 7. Yeah.
Yeah.
That's safe range. Let's put this to test. Let's see if our audience agrees to this, or they think it's going to be more or less.
People, I think your question was very clear. Calendar year. So we have time till next April. By which time I think the last quarter things might improve. Maybe you will see that uptake into 7. So there my answer. Okay, I'm not giving you a range. I'll give you a number, 7 gigawatt.
All right. So I think Venkat, Deepakji, both of you, you're bang on. I think we've got about 71% of people who believe it's going to be 7 gigawatt for the calendar year. I think that's just bang on. Great stuff. All right.
Thanks, Vipul.
All right. I think with this, I'll be bringing in Mr. Gautam Samantha. Welcome, sir. Deepakji, I'll come back to you on
Yeah,
the
yeah.
very soon.
Hi, Vipul. Can you hear me?
Yes, I can. So,
Yes.
so I've saved you for the last,
Yes.
and I think that your knowledge on the technology, I think Lim is going to be absolutely of your knowledge, which I'd like you to quickly move on to your questions. But I think before that, just like I think I've asked Venkat, I want your opinion on one of the questions, which is going to be, as per you, what is the operational manufacturing capacity in India, both module and cell combined? Where would you put it right now, as per you?
Okay, install capacity, what we have 10 gigawatt in module, and cell is,
Operational?
cell is, but operational is maybe around 20%, 2 gigawatt in the module level, cell level is 1.5 gigawatt. That's all.
All right. Let's see what our audience has to say on this. Right. So here we have the results. So I think yes, it's safe to say we are somewhere between what you mentioned, about 2.5 to 3.5 gigawatt.
Thank you, Vipul. Right.
All right. So Gautamji, what are your initial views on the 500 watt high power module? You can just switch on your camera as well.
Okay.
Yes.
Yes. Before going that one, I mean, I must thank to Lim and all of his colleague, right, from the Helena, Mr. Ku, Mr. Bosco, Mr. Jerry, probably I spent at least 10 visit, 2 audits, maybe more than 50 days inside the factory, probably it is unbelievable, I mean, the kind of the facility in the headquarters of Changzhou, right? Visiting from 2014 deeply, and yes, I have seen a lot of technology change, what Liam has already projected, because with my experience, I am working in the microelectronics in 1985, where 4-inch dia round wafer, and these are all for different devices, right? But today the solar is a bit different, right? From 2004 onwards, we have changed the changes, right, from 156. Now today, this year 158.75, then 166 to 210. So in terms of getting a crystal growth, what Mr. Deepakji was asking, 210 is not the big challenge, After that, wafering means the separations of the wafer, because this is a very, very large wafer. There is always a a kind of sticking together, and wafering inspections, and particularly in the cell level, when a lot of things, right from the cassettes, right from the different the high temperature tubes, a lot of inspection system, handling systems, such a thin wafer as a large substrate is yield is a big issue, very big issue. But I believe that Trina has done all sort of R&D, before putting in the 210 millimeter wafer, which is called the 500 wattage, But in terms of the size of the wafer is not that large. Deepak, I am coming to their questions, particularly you told that there is a 20-25% area on the large area. It's not 25%, it's much lesser than that. And even in the high wind speed zone, as the wafer or the cell is cut in 1/3, instead of getting a full cell, which is prone to your micro crack, but instead of when you cut it 1/3, you get a better mechanical strength, better electrical isolations, and mechanical stability in terms of the same wind in a field, right? Slightly larger, but what I will say, there are different areas. As far as the manufacturing is concerned, is not the big issue. Big issue after that is the transportation, loading, transportations, and handling at the particular site. When we take the modules, when it's reaching at the site, and we have been installed within 10 days, the challenge is that, how quickly put in this thing into the power plant, in your table, but there are a lot of unskilled labor. We give the training, but people are working 24/7. So if they are not properly handling it, there is a challenge that creates a micro crack, which may not be visible now, maybe after 2 years, 3 years, or 5 years down to the line, right? So I'm coming back to the 500 watt is modules, I mean, like when the substrate like 158.75, then 166, and then coming to 210. So the challenge in terms of not only the change of different capex as well as the equipment in the wafer and the cell line, how did you see that you can handle, this kind of the change in the industry, within certain period, within 1.5 years, right? Name, this is your question.
Thank you, Mr. Gautam, on this question. So I think, it's not whether we want to handle or we do not want to handle, but it's really the market dynamics is moving so fast that we are actually trying very hard to catch the market dynamics on how we can support our customers on this requirement on higher power bin, better modules, different technology. So that's why from Trina perspective, we are doing all we can to see how we can bring all these different things, put it together, and offer some module that can be accepted by the market and help our customers to achieve their targets and goals.
Okay, in terms of market share, say if you talk about 2020 is gone 21, so what will be kind of a market share you want to capture with the 500 watt modules, right? 10%, any number, 10%, 20%, because I'll ask next questions, right?
That's a competitive question. I'm sure Lim wants to stick.
Yeah, because see, basically any high wattage or which is called the premium based modules, is always a showcasing for any product. I mean, not talking about any Trina anybody's, right? This is in general, right? So it is a maturity of the market, how as a developer we use it. It is not the manufacturer's issue. Issue is also from the developer side, right? I'm coming back to the bifacial, the module, which will be say installed with a single axis tracker, but there is a several issues on the rear side LID. How did you address those issues, right? Can you address on those questions? Rear side LID, light index degradation, degradations on the rear side.
Yeah, I understand. So I think, for bifacial itself, if you look at the market, for bifacial, we have been gaining popularity and deployment from the past 2 years. We see more and more developers are being open and consider bifacial as another method to increase the power generation. So I think for the backside LID, this question, I mean, to be honest, we are still looking at it on how to manage this LID process, which from the front and from the back. But as of now, I think for the backside, we are looking at in terms of the bifaciality as the first factor to compare the power between the front and the back, and then from there, we will look at how the LID is going to come into the picture. Yeah.
Sure. Thank you. So I have a question for Andrew.
Gautamji,
I have associated question, Vipul, just what Gautamji have asked. Lim, as a manufacturer, means there are all manufacturers are coming with bifacial, what you are telling. My question is that as far as simulation techniques are concerned, now when I am talking about the simulation techniques, these should be the bankable simulation techniques which the bankers and institutional investors should accept. Are the manufacturers coming up with some solution? Because there is a lot of ambiguity. What should be the albedo? What should be the reflected light? Depending upon the layout, what should be the reflection? And all those things affect on the rear side generation. And there is no set techniques. It is only certain beliefs which manufacturers are trying to propagate, but there is no scientific set technique which is acceptable by the bankers. So there is where one major challenge comes in using the bifacial technology.
I think Andrew can address these questions because they have a like tracker package they want to give it, and they can give an warranty on your at least 30% in power gain from the albedo and something like that. Lim, yeah, Andrew is here.
Yeah, Andrew, please go ahead.
Yeah. Hi, can you hear me?
Yes.
Yeah. Apologies, I had some internet connectivity issues there, but I think the question was about how can we provide the assurance on the additional generation on the underside from the modules and the trackers. Is that correct?
Yeah.
Yes.
Okay, thank you. Yeah, so we know that's a key part of the jigsaw to add that as a differentiated offering in the market compared to disaggregated tracker and module solutions. So we are very heavily engaged with a number of third parties, including the likes of DNVGL, to validate our extensive test data, test verification data from Trina modules onto Trina Pro solutions. So they're currently trawling through that data, and we expect that that verification to be ongoing. But we are the early signs are that there is a meaningful boost from such things, not just from bifacial and trackers, but also through the smart tracking algorithms that I mentioned earlier. And then the next phase of that will be to package that up in a component performance guarantee where Trina is able to provide these assurances and hopefully enable our clients to attain lower financing costs. So it's a bit of an ongoing question at the moment, but we're working very hard to provide those assurances to the market.
That's good. That's good.
Andrew, one question I'd like to put up to you, which I've got from our attendees. The first one is, what's the kind of warranty which is being offered on trackers? And the second one is, what factors are you considering in deciding the DC overloading ratio? For example, what's the normal DC overloading ratio in Australia for, say, a location in New South Wales?
Sure. To answer the first question, warranties are 5 years on electrical components and communications components, 10 years on the mechanical, and I believe actually a 20-year on the galvanization, as long as the structural elements are in a C3 category location or below. So that's according to C3, according to different international standards there. In terms of DC to AC ratio, we're seeing in the order of 20 to 25%. That's before any kind of derating from operating at a non-unity power factor for the inverters to provide various grid support functionality. So if you assume the plants are operating at a unity power factor, then it's ordinarily, in Australia at least, about 20 to 25%. What we are seeing in the market and probably try and steer our customers towards is probably trying to dial that back a bit to maybe knocking 5% off that, maybe down to 25% to 20. That's because obviously the bifacial gain, there's more current being pumped through the system, so you need to size your associated switchgear and fuses and cable cross-sectional area upwards accordingly. But also things like checking the short circuit current, the maximum short circuit current input in the inverter can take that slightly higher current. I'm not yet familiar with the code in India, but certain codes globally, they obviously need some kind of safety factor for current, and then certain codes are adding an additional 30% onto that for additional safety factor. So yeah, probably around about 15 to 20%, I would say.
All right. Okay, I'm going to bring Anika in on this. Anika, hi. Can you come on in? All right, Anika, are you there? Okay. No. All right. Andrew, and another question I think which I'd like to put up to you is what kind of markets are Trina Pro Solutions aiming at? We've got some questions from Bangladesh, some from Sri Lanka. What are the markets that you're looking at for these solutions?
Sure. So good question. Thank you. So yeah, I think first and foremost, front of meter and utility markets. I think possibly commercial and industrial, possibly behind the meter, has a part to play in that. But certainly we're targeting going after the market of really big projects, and then down to a size, at least at this stage, of 10 megawatts or above. And I think, in terms of markets, Australia is certainly a priority market, although for various grid challenges and other issues, that market seems to be contracting slightly. So certainly India, Vietnam, we're trying to address that market with the recent release of the feed-in tariffs there. There's other interesting markets in the wider APAC region, like in Malaysia, LSS3. There seems to be a growing appreciation of the value adds of trackers, and that's interesting with Malaysia being, very close to the equator, to address that point I was mentioning earlier. So there seems to be a growing comprehension and level of comfort in the industry with single axis trackers, even kind of, pushing the APAC definition to its limits. Israel is looking like an interesting market for us as well. For various characteristics, a good solar resource and typically a good albedo and so forth. Bangladesh, I know we're probably trying to make a determination on the Bangladesh and I think Pakistan market as well in due course. All right.
Okay, so Gautamji, one last final question from your side to Andrew, and then I'll have to initiate for closing remarks.
Yes, if you are installing a bifacial module, so fixed tilt versus single axis tracker, can we install with the fixed tilt and make a which is called a cost-effective model, particularly, and not in India, particularly we have a project in the west part of India, northwest part of India. So that's my questions, with a fixed tilt, right? With a bifacial model.
Okay, yeah, good question. Thanks, Gautam. First and foremost, for bifacial, I would, on a fixed tilt, I'd probably recommend to tilt the angle of inclination a little bit higher to enable a bit more diffuse irradiance to access the underside of the cells. I think the old debate is about do we go fixed tilt east-west or single axis tracking? And obviously, if you go east-west, then you forego any kind of bifacial boost on the underside, typically because the east-west are like that and nothing can get in underneath. So I think to really leverage and monetize the full value stacking, as I mentioned earlier, of going with bifacial, really it has to be in a single axis tracker application. Obviously, typically, especially in a 2 portrait configuration, these trackers are higher off the ground and more widely spaced, enabling much more diffuse irradiance to strike the underside of the cells.
All right, great.
Thank you. So only one question last, in case of a tracker, the rear side cleaning, how do you clean it? So that's my question. Like in the front side, we have a dry cleaning systems, robots and all, right?
Yeah, that's a good one. So we have robotic cleaning solutions. I think over time, possibly they might be value engineered to perform some kind of cleaning function on the rear. I think it's up for debate. It's probably very site specific as to how much soiling is accrued on the underside. Unless you're very, very heavily, there's multiplier factors, like if the site's right next to an agricultural region or a coal mine or something like that, then the soiling may be prevalent enough to justify cleaning the underside. But at this stage, I'd probably expect most sites to not justify the additional O&M OPEX for the additional yield.
This is because coming when the rain or something with the gust, on the rear side, the dust is coming and sticking over there, so during that time only, we need,
yeah, there's also smart, we can pick up on the rain sensor in the monitoring, and in a rainfall event, we can stow at a very high angle to really make the most utilization out of the precipitation that we're getting a free clean on the front.
Self-cleaning or something like, right? Okay,
yeah, exactly. So maybe maybe at a steep stow there might be some additional cleaning effect if we do that as well.
Thank you very much. Thank you. It is a fantastic.
Okay, so I think that's a wonderful session. We unfortunately do not have a lot of time for Q&As. I think if it was a physical meet, we would be sitting there for about 6 to 8 hours discussing a lot of things. And I think these topics do require, the nature of discussion is such that we require a longer time. I'm sorry if I had to cut any of the panelists for questions, but I think on the larger good, there is a lot that we are going back with. We've got a lot of insights. There's no doubt in saying that Trina definitely has been one step ahead with the launch of Pro Solutions as well as the 500-watt power modules. It is one step ahead towards bringing in new solutions in the new era. I think post-COVID, it is going to be new era, and we have significant solutions coming in from Trina on this. So I think with this, we would be finally moving on to closing the session. A lot of attendees have asked presentations. I think we will be sharing this with you post the event. So I think if there are any further questions you would like to ask, and we'll try and get back to you on this. Also in India, I think it's lunchtime. We are way beyond we are a little beyond our scheduled time. So I think all the people, let's have a good lunch and meet soon for our next webinar. So thank you, Trina. Thank you, panelists, and thank you all the attendees who've joined. Have a wonderful day.
Thank you, people and Solar Quarter team. Thank you very much.
Thank you.
Thank you.
Thanks, everyone.